Kia ora. This interactive by PCCL shows how to calculate the molar mass of an average atom. So you look at all the isotopes in the natural abundance in terms of their percentage and do the calculation to get the average molar mass. So what they've shown here is the most common isotope. And if I click on here, then you will see how the calculation is done. So 99.985% appears as the protium isotope, 0.015 appears as the deuterium isotope. They don't actually show the tritium isotope because that's such a tiny amount. And if we calculate to 1 decimal place, we take the percentage and of the protium isotope mass and add it to the percentage of the deuterium isotope mass, and you will get an answer much closer to 1, of course, because most of it is 1. So it's 1.0. Helium, again, most of it appears as helium-4. So if we take the percentages of the respective isotopes, we get 4.0. Lithium, there's quite a chunk that's lithium-6 compared to lithium-7, and it's enough to actually bring the molar mass down below the mass of the most common isotope of 7. So you'll see it's 6.9. Beryllium, there's only one isotope, so it's 9.0. Boron, there are 2, and 20% is the lower massed isotope. So although 11 is the most common one, the molar mass is actually 10.8 for an average atom, because 11 times 80% plus 10 times 20% comes to 10.8. Carbon, there are 3 isotopes, but because most of it is carbon-12, to 1 decimal place, the molar mass is going to be 12.0. Similarly for nitrogen, most of it is nitrogen-14, so the average mass is 14.0. And again for oxygen, 16.0, because most of it is oxygen-16. Fluorine, there's only 1 isotope, so it'll be 19.0. Neon, because quite a chunk, 10% is from the heavier isotopes compared to neon-20, the molar mass for an average atom will be 20.2 grams per mole. Sodium, there's only 1 isotope, so it's dead easy, no calculation. Magnesium, 3 isotopes, and actually quite a chunk, more than 20%, are from heavier isotopes. So you'll notice that the molar mass is higher than 24, which is the most common isotope, is 24.3. Aluminium, only 1 isotope. Silicon, there's still quite a chunk from heavier ones, so it just makes it higher than 20.0. It's now 28.1. Sorry, 28.0. It's now 28.1. Phosphorus, only 1 isotope. Sulfur, again, there is about 5% coming from heavier isotopes, so it brings it up to 32.1. Chlorine, you'll notice there's no chlorine-36, but there is 3/4 of all chlorine is chlorine-35, 1/4 is chlorine-37, which if we take 1/4 of 37 and add it to 3/4 of 35, we get an answer of 35.5. So the mass of an average chlorine atom is 35.5. And argon, you'll notice most of it is argon-40, but we've got some coming from lighter isotopes, so we have it slightly lighter than 40. Its average mass is 39.9. So kia ora, and hopefully now you know why some of these numbers for average atoms are 0, but others are higher and others are lower. Kia ora.